discuss about linear wave shaping. Linear wave shaping is nothing but the process by which the non-sinusoidal signal gets altered by transmitting through a linear network. So first of all, we discuss about linear elements. Linear elements are resistor, capacitor and inductor. Because they obey the linear property, like if you take for a resistor, V is directly proportional to I. So we introduce a constant of proportionality known as R into I. So for every change in V, there is a change in I. If you see the characteristics of V and I, so voltage and current, we can represent the resistance lies between any one of this region from here to here. So we can define the graph as resistance graph, right? So now, apart from resistor, we once again will go with the capacitor. Capacitor is an passive element which stores energy in terms of electric field. So we have a relation V is equal to 1 by C integral I of t into dt. So once again, if I of t gets changed with respect to time, the voltage across the capacitor also gets changed. So here, so for every change in V, there is a change in I, or for every change in I, there is a change in V. So we can define, once again it obeys the linearity property. Once again, if we go with the capacitor, inductor coil, inductor, so we can define V is equals to L into di of t by dt. So here also the same principle holds good. For every change in I of t, there is a change in V. So it also obeys the linearity property. So we can define resistance, capacitor, inductor. These three elements are said to be passive elements. Once again, these elements are we can classify into linear elements. As they obey linearity property, in general, for a linear graph, we can define the curve y is equals to mx. Y is equal to mx is nothing but line passing through origin, which we can define the graph as a linear graph, which varies from 0 to some particular value. Now, linear wave shaping is nothing but the process by which the non-sinusoidal signal gets altered. It is nothing but, so first of all, we will define what are non-sinusoidal signals. Non-sinusoidal signals. So signals which are non-sinusoidal signal. First we can define step signal. Second one we can define pulse signal. Then third we can define square wave. Fourth we can define a ramp signal. Fifth we can define exponential signal or input we can do. So these are the different types of non-sinusoidal signals we can define. Now, if I apply these non-sinusoidal signals to a linear network consists of R, L, C elements. The wave shape gets changed. This is known as linear wave shaping. When we apply different non-sinusoidal signals to a linear network, the shape of the wave gets changed. We can define this as linear wave shaping. So we can classify the corresponding linear wave shaping networks into two categories. It is either a high pass or low pass RC network. So first of all, we go with RC network or RL network. The third comes to RLC network. So first we will see about RC. So let us design a circuit with the help of a resistor followed by a capacitor. Now let us apply input first of all with a stepping. So let us assume this is resistor, this is capacitor. Let us take the output voltage across capacitor. This is my input voltage VA. Now here the input voltage Vi is a step signal. Now we can represent the step signal with, this is T, this is Vi, and its voltage is constant V volts. So we can represent mathematically the step signal as Vi is equals to V volts for t greater than 0 and it is equal to 0 for t less than 0. So this is the step signal. So up to t less than 0, my input voltage Vi is equal to 0 volts. When it is t greater than 0, my input voltage Vi is equals to V volts. Is it clear? Now, if I apply this step input to the corresponding RC network, how the output voltage varies? As we know that we have capacitor reactance is defined as Xc is equals to 1 by omega into C. So omega is nothing but 1 by 2 pi F into C. Now we can classify the given RC network will behave like a high pass or low pass circuit. Now we know that, so from this Xc is inversely proportional to 1 by F. For low frequency means ideal values, if you take F is equal to 0, then Xc is 1 by 0, it corresponds to infinity. Once again, if I take F is equals to infinity, then Xc is equals to 1 by infinity, it means that Xc is equal to 0. So the reactance of the particular element capacitor is 0 or infinity, it completely depends on the values of frequency. Now by substituting the reactance of capacitor either 0 or infinity, how the circuit will behave with respect to input. Now if I go for low frequency F is equals to 0, Xc is equal to infinity, the capacitor will almost act like an open circuit because of infinite reactance. Now the modified circuit I can define with, this is Vi and we have a resistor and this is almost open because Xc is equals to infinity. In this case, output is almost approximately equal to input. Output is almost equal to input. Now coming to the point of next case, if I take Xc is equal to 0, it almost acts like a short circuit. Xc is equal to 0, then it almost acts like a short circuit. Then the output voltage V0 is equal to 0 volts. So we are not going to get any signal when the capacitor reactance is equals to 0. So we can simply say that whatever the signal, it may be either low frequency or high frequency. If a high frequency signal is transmitted, the capacitor reactance is 0 and output voltage is equals to 0. Then if the frequency is a low frequency signal, the capacitor reactance is infinity and it almost acts like the open circuit. Whatever is applied will be transmitted. So we can define for high frequencies, the capacitor reactance is 0. So then output voltage V0 is equal to 0. So we can simply say that it is a low pass filter. Okay. Then we'll go with one more case, interchanging of resistor and capacitor. Now replace resistor with capacitor here and capacitor with resistor here. Then if a capacitor is placed here and resistor is placed here, once again we'll see for low frequency capacitor reactance is infinity. If infinity, it means it almost acts like an open here, and here we have a resistor. If I take output at this point, the output voltage V0 is equal to 0 in this case. Now coming to this case, if capacitor reactance is 0, it almost acts like a short circuit. So here Xc is equal to infinity. Then once again in this case, V0 is almost equal to Vi. So we can define the corresponding circuit is a high pass RC circuit. So by interchanging the resistor and capacitor in a particular RC network, it will behave either as a high pass RC circuit or low pass RC circuit. Now if you see the VA characteristics of high pass RC and low pass RC, let us take a circuit, resistor and capacitor. This is my input voltage Vi and across capacitor I am taking output voltage V0. I can take this is capacitor and this is resistor. According to Kirchhoff's voltage law, algebraic sum of voltages in a closed loop is equal to 0. Then I can simply say Vi minus Vr minus Vc is equal to 0. Now, if I am applying a step signal is nothing but its voltage varies from t is equal to 0 onwards. So at t is equal to 0 or t less than 0 or t is equal to t minus, my input voltage Va is equal to 0 volts. When t is equal to t plus, just after t is equal to 0, my input voltage Va is equal to V volts. Okay, so if I see just t is equal to t 0 minus, my input voltage 0, and t is equal to t plus, just after t is equal to 0, suddenly my input voltage rises from 0 to V volts. But we have a capacitor, and the property of the capacitor is capacitor does not allow sudden change in voltages. So it will not change instantly, but it will changes exponentially. So what happens is, if you see the Kirchhoff's voltage law, initially I am applying 10 volts, Va is equals to 10 volts. As we defined that the voltage across capacitor cannot changes to 10 volts. So initially the voltage across capacitor is 0 and the voltage across resistor is 10 volts. Then slowly the voltage across capacitor rises exponentially. This will change to 1 volt, then this will change to 9 volts. So this is voltage across resistor and this is voltage across capacitor. Then after t is equal to some 5 Rc or 10 Rc, automatically the voltage across resistor comes to 0 and the voltage across capacitor reaches to 10 volts. It means that capacitor charges to the maximum value of input voltage for large time constant. So we introduce one more term known as tau. Tau is nothing but Rc, where we can define this as time constant. Time constant, because the units of tau is also equal to seconds. It also equal to seconds. So by keeping the values of R and C, we may get either large time constant, short time constant, or medium time constant. Okay. So here we have two parameters. One is Rc. This is circuit parameters, and next parameter is tau, which is nothing but time constant of the circuit. So here both tau is equals to Rc. So here we have one thing is time period and second one is time constant of the circuit is tau. We are applying some signal whether the capacitor charges within the time period or above the time period. It completely depends on the values of R and C. Okay. Then we will go with the mathematical analysis of high pass and low pass RC circuit. So by applying KVL and necessary mathematical equations, we will get the output expression for low pass RC is V0 is equal to V into 1 minus e power minus t by RC. This is the output voltage expression for a low pass RC circuit. Low pass RC circuit. Then similarly, if I go with the high pass RC circuit, after calculating mathematical with the help of Laplace transform, we can get output voltage expression is V0 is equals to V into e power minus t by RC. This is the output expression for RC, high pass RC circuit. This is high pass RC circuit. Now for different values of t is equals to 1 RC and 2 RC and 3 RC. Similarly, if I go with 10 RC, let us see how the graph varies with respect to t. V0 versus with respect to t. Now if I substitute t is equals to 1 RC, okay, just I will conclude within few seconds. Then I may get the output expression for high pass RC for different values of t is like this, and for low pass RC circuit I can get the output expression, output voltage expression, like output graph will be like this. So I can define V0 is equals to V into 1 minus e power minus t by RC. This is exponential rising curve. This is exponential decaying curve, V into e power minus t by RC. So thank you so much for listening my lecture.